So in today's lecture, I will be doing the method of successive approximation. Okay, so first what you'll have to do is consider this integral equation. Okay, what is that integral equation? Y of x is equal to f of x plus lambda integral from a to b k of x comma t y of t dt, and take it as 1. Okay, now this lambda, it belongs to the real or complex, and k of x comma t is my kernel. Rest all know known functions, what are known functions, all that. Okay, in the previous video I have already explained you all about this. So now let y naught of x denote the zeroth approximation. Okay, let this y naught of x denote the zeroth approximation to the solution of this y of x of equation 1. Now take y naught of x is equal to f of x. Then what I'll have to do is, this is my first zeroth approximation. Okay, this. Now the first approximation to y of x is given by y1 of x is equal to f of x plus lambda integral from a to b k of x comma t. Now instead of this, for this the first approximation is y1 of x. Okay, and here it will be y naught of t. Y naught of t I have put, okay, here dt. Okay, so now this is equal to what? Y1 of x is equal to f of x plus lambda integral from a to b k of x comma t. Now what is my y naught of t? Here my y naught of x is equal to f of x, but if it would be t, then here also it would be t, right? So now put f of t dt. Now what about the second approximation is given by y2 of x is equal to f of x plus lambda integral from a to b k of x comma t y1 of t, this. Okay, y1 of t I will put dt and take this as 2. And suppose if we continue in this way, what we are going to get is y0 of x is equal to f of x and ym of x is equal to f of x plus lambda integral from a to b k of x comma t ym minus 1 t dt. Okay, and consider this as star. Now what I have done over here, if consider this m is equal to 2. Okay, so this is 2 minus 1, it will be 1, right? So same way what I have done, suppose m is 2, then 2 minus 1 is 1, like this way we have to. Okay, this is in general form. Next is what? The limit of this m tending to infinity ym of x is equal to y tilde of x, then y tilde of x will satisfy given equation 1. Okay, thus we have defined the sequence ym of x of approximation solution of equation 1, which will find the exact solution of equation 1. Okay, so we got the sequence and all that. So next I will do from 2. Now from equation 2 what I am getting, so this is what first part is from, if you continue you will get this. Okay, and now from 2, now I will write this 2 here. Okay, y2 of x is equal to f of x plus lambda integral from a to b k of x comma t y1 of t dt. Now this is equal to what? F of x plus lambda integral from a to b k of x comma t. Now what is my y1 of t dt? Now okay, so here this is first approximation, right? y1 of t in terms of t I have to write. Okay, so wherever there is x I will be replacing it by t, and wherever there is t I will be replacing it by u. So what I am going to get is f of x plus lambda integral from a to b k of x comma t. Now what is this? F of x was there, right? I have replaced it by t plus lambda integral from a to b k of t comma u. Wherever there was t I have replaced it by u, and wherever there was x I have replaced it by t. So k of t comma u du dt. Now this is equal to f of x plus lambda integral from a to b k of x comma t f of t dt plus lambda square integral from a to b k of x comma t, integral from a to b k of t comma u f of u du dt. Now what I have done over here is, see, now this was equal to what? F of x, write it as it is, plus lambda, write it as it is. Now what I have done, this part I have to multiply with f of t first, okay? That's why lambda integral from a to b k of x comma t f of t and this dt, plus now lambda into lambda is what? Lambda square, okay? Then integral from a to b k of x comma t, then this integral I have to multiply this part with this, right? This into this. So now integral from a to b k of t comma u f of u, where is it? So integral of k of t comma u f of u du dt, okay? Here, so I think I have missed one part over here, okay? Let me see which part it is. So this was from y1 of t, right? So here there was f of u, right? F of u, just put it f of u, okay, over here. This instead of this, here it is. Okay, here you will have to put f of u du. Put k of t comma u f of u du dt, okay? So that's what I have done. Now this into this, k of x comma this t comma u f of u du dt, okay? Here, now what I have done to this is, I have changed by changing the order of integration, what I will get, y2 of x is equal to f of x plus lambda integral from a to b k1 of x comma t f of t dt, plus this f of x from here, f of x plus lambda integral from a to b. I have done here k1 of x comma t f of t dt. Why? Where k1 of x comma t is equal to k of x comma t. So wherever there was k of x comma t, I have replaced it by this, okay? Here, then f of t dt, then plus lambda square here, plus lambda square, and instead of this, okay, what I have done, integral from this integral from a to b k2 of x comma t f of t dt, where my k2 of x comma t is equal to integral from a to b k of x comma u into k1 of u comma t du, okay? Next is, let y3 of x is equal to f of x plus lambda integral from a to b k of x comma t y2 of t dt. Now here I have done it directly, okay? y3 of x is equal to f of x plus lambda integral from a to b k of k1 of x comma t. Now here for this part, what I have done, lambda integral from a to b k1 of x comma t f of t dt, first part I have taken with this part, and then plus this I have written, okay? Plus lambda square integral plus this lambda square integral from a to b k2 of x comma t f of t dt. Then it is y3, right? So plus lambda raised to power of 3 integral from a to b k3 of x comma t f of t dt, okay? Next thing is, in general form, how I written this, how I have written this, k3 of x comma t is equal to integral from a to b. Now for this it is, okay? So k of x comma u into k2 of u comma t du. In general, ym of x is equal to f of x plus this summation I is equal to 1 to m lambda raised to power of I integral from a to b ki of x comma t f of t dt. Okay, now where this my ki of x comma t is nothing but equal to integral from a to b k of x comma u into ki minus 1 into u comma t du. Now this is equal to integral from a to b ki minus 1 x comma u into k of u comma t du, where ki of x comma t is iterated kernel. Next page I'll turn. Now limit of m tending to infinity, ym of x is equal to f of x plus summation of I is equal to 1 to infinity lambda raised to power of I integral from a to b ki of x comma t f of t. This series is called Newman series, okay? And here I am done with today's lecture.